Hello, this is TelecomTV. I'm Martyn Warwick and I'm talking with Martyn Taylor, CTO of Metaswitch. Martyn, we are old, sparring partners, colleagues, friends.
Drinking buddies.
Drinking buddies, that's a good way of saying it, absolutely. We've had a few pints over the years, that's true. I'd like to begin by putting something to you. Telcos have been a bit wary of NFV and the fact there's a lot of IT involvement in NFV because, of course, they have to provide very high standard SLAs, continual dyne tone, availability of everything. How do you get telco-grade availability from an IT-grade cloud?
This would appear to be a bit of a paradox, I suppose. IT-grade stuff doesn't deliver anything like the level of availability that telcos need. 5 nines means 6 minutes a year of downtime, absolute maximum. That's a target that IT-grade stuff just doesn't aspire to. So, of course, NFV is all about trying to make use wherever possible of IT-grade hardware and software. The cloud component of that, and it's an essential part of the stack. If a cloud fails, then the services that are running in it, will stop, and so availability of that cloud is a critical component of this. Actually, it turns out to be not that hard to solve the problem. You just have to make sure that your service is distributed across at least 2 completely independent instances of the cloud stack, so that if a cloud instance fails and takes part of the service out, the rest of the service carries on running, and it's possible to engineer that in a way that the service from the point of view of its users is completely unaffected. So this is simply about understanding that cloud is a single point of failure potentially, just like any other component in a complex system, and provided you've got redundancy in your service is spread across multiple cloud instances, then you absolutely can achieve the holy grail, the 5 nines availability that telcos are looking for.
Are telcos aware yet that such solutions are available? Because the number of service providers I've spoken to said, they want it, but they're not sure it really exists.
I think there's a basic misapprehension here that often people look at cloud as a kind of single continuous environment and think that in order to get 5 nines availability, they have to make the cloud itself at least 5 nines available. One day it might be possible to do that, but it's a very tough thing to do. And right now, most cloud environments, they're 3.5 nines if you're lucky. Even if you implement the HA architectural approach that those cloud systems offer. So they're nowhere near reaching the target. And our view is actually it's pointless striving after that target when you can solve the problem so much more easily. Just as it's pointless to try and build a piece of hardware that's 5 nines available when you can use cheap hardware that's only 3 nines available and work around that by having the application take care of the case where hardware fails. In our view, the cloud is just another piece of the stack, like an operating system or like a server, and if it fails, we just have to work around it.
Do you think that service providers, not really sold a pup, but took on the idea because of the hype that surrounded NFV, which is now dying away to a considerable extent, and we're seeing reality emerge? Do you think that they had the notion imposed upon them, or they thought it up themselves, that you could make the cloud completely secure and completely carrier grade from start to finish?
I'm not sure how much they thought about this from the outset. I mean, it's very clear right from the original white paper that their intention was to use IT-grade stuff to support NFV. But I think the detail of how you actually accomplish that, has only recently started to emerge, I guess. But this isn't rocket science. I mean, as long as you view the cloud software as simply one of the components of the stack and something that is as likely to fail as any other part of the stack, and as long as you design your application so that it can withstand the failure of that part of the stack, then you're good. So there's nothing wrong with their original vision. I think it's just a question of, okay, well, what does that actually mean in practice? It actually isn't that hard to distribute services across multiple clouds. Although one of the problems we're seeing at the moment is that many orchestrators actually aren't able to do that. Orchestrators, often are designed to view the world as a single cloud, and that's problematic. So there are definitely some gaps to be filled, but from the point of view of architecture, the problem is absolutely soluble.
Let's move on to hardware acceleration. There's a new generation of intelligent network interface cards out there. Metaswitch is involved. What are the benefits? How's it working? What's it for?
Well, we're always looking at the evolving world to see how can this make things better from the point of view of network operators and in particular, obviously, for the performance of our own virtualized network functions. There are some tasks that our software does which put a heavy workload on x86 CPUs, and there are certainly some things that intelligent NICs can do with network processor silicon that maybe we could leverage. Now, some might argue, well, now you're kind of getting away from standard IT grade stuff. And I think actually I would argue that some of these NICs are beginning to become so mainstream, both from a cost point of view and also from a point of view of acceptance. We are beginning to see the mega scale data centers embracing this technology in a pragmatic way. There's specialized kinds of processing power on those NICs that can be put to good use for network workloads, and we're just all about exploring. Well, how could they help us and therefore help our customers?
Interesting. Martyn Taylor, as usual. Thank you.
Thank you.